All right, welcome back again in this second part of a tutorial of mill-turn machining in NX operation. In this video, we start to define the operations. The part that we're gonna look for is the part that is shown here. We're gonna have first defining the facing, roughing, and finishing the part from the outside diameter. And after that, we're gonna machine the slot in the face of the part and then 3 slots on the side of the operational part, and then we're gonna have drilling on face of the part and then the um, side slots, and then after that cutting the part followed by the finalizing the face of the back of the part in the second spindle. The first operation to follow is to create the facing operation or roughing of the facing, followed by the second operation of the outside diameter roughing. We can simulate those ones. These steps are rather simple and similar to the turning operations, except the minor changes in definition of the geometry that we're gonna work on the settings of the operation. Then after that, we're gonna have a outside diameter finishing of the facing and also the outside diameter. So noting that the next one will be on moving on the machining the side slots. So note that in this view, if you can see on the right view, the tool is actually machining the slot on an inclined angle. And if you can see the left side of the view, you can see that it is actually the workpiece that is rotating. And the cutting tool is only moving in a Y direction in the machine that we have in the lab, and it's moving on the slot, on sliding on the component of the machine itself. However, on this view, it looks like that the tool is rotating, but in real life, actually the workpiece is rotating. So this is also things to take into account when we are defining the machining on the slots, either on the faces and on the slots. And that is why we are defining on the methods milling on the polar, and setting the methods on the mill polar and the geometry are on the machine coordinate system mill, is defining that the post processor will also um, generating us a milling output as opposed to the lathe or turning output. For this one, then we are defining the cutting area and the wall, and then after that we are making sure that we are defining the non-cut movement and also defining the correct access of the tool itself to be able to first of all correctly machine the tool so that the axis of the tool is perpendicular to the surface that we are going to machine, and also saving time on idle movement of the tool itself. So here are how to define the vector normal to the surface that we are going to machine and so on. And then after that, we're gonna copy the same operations 3 times for these 3 different slots on the side. And then for the part that we are going to use for the demo part of the course, at the end of the course, is that we have a hexagon to machine. So it's going to be 6 of these floors need to be copy pasted and then um, uh, copy pasted and then modified to be specifically defined on that each side of the hexagon. So here are just shows how to copy paste that one and how to modify, regenerate the toolpath and verify the toolpath. All right, let's switch to the NX cam, and we will define these steps that I show quickly on the slides on our NX. So the first one was the facing operation. So simple creating operations. And then here we are having the mill turn essential. And then we're gonna go and choose the facing. So we have the facing here. The program one is this one. The tool, for example, let's say that we're gonna use this 80 for roughing. The geometry, it was something that is important to take into account. Containment main, because we are on the main spindle, so we are going to manufacture the um, left side component first, and the methods to be chosen is the lathe rough. So for example, we can just call this one as it is facing and so on. We can first see that we can already generate these ones, or to be able to see it better, we need to just go on the right side. So this is how it's gonna do that. Or we could actually do the cutting region, and we can see that the cutting region is considered both facing and the outside diameter. So perhaps this is something not we are not looking for. Let's see if we can first get rid of this one, or let's see if we go to um, menu, edit, and then show and hide. If we can hide this plane. If not, it's not a big deal, but it's a little bit cleaner if we can just do this body sheet cleaning. Let's say select all. Yes, so now I get rid of this plane now. So it's clear better now, the cutting path. So we have both facing and the outside diameter, and this is something we would like to avoid, and only having it with the face of the part. So one way to do that is just moving this axial plane that now is -5, for example, to the number that it goes ahead of this. So this is still considering that one. So let's move it to 32. And now it looks all right. And it's actually left a bit of material for the finishing. So rather than if we would put 33, we have even more material for the finishing. So 32 should be all right. We have still the material for the finishing aspect also. After that, we click OK. And then, well, anyway, this is the facing operation. We could put also this one omit as it is here. And then I don't want to repeat that, but anyway, better to repeat it rather than missing it. You can define the feed and speed here. So what is your spindle speed? So for example, in terms of a RPM, spindle speed, let's say, for example, 750. So these are something that you calculate. The feed rate, you need to see it from the tool based on the catalog that you are using, the type of tools and the material that we are machining. You can figure this out and put in the right number. And then we have the other cutting parameters, for example, here that you can value these ones to enter this value correctly. Other than that, we can also um, let's see. Well, this is now I can see that it seems to be only one movement or one pass of taking the material. I can verify here and simulate the pass. So I can see that we have only one movement. So now I put, for example, the maximum of 1, and you can see that now I have more tool path, so that each time maximum we are taking 1 millimeter of material. So this is something that you should calculate and see. Otherwise, then there are different type of other parameters and settings that you can take into account, different type of a cutting strategy and so on. We just leave it out for now. Let's generate this and let's verify how does the toolpath look like. We can see that we have 3 different view, or you could actually see the material removal also. If I go from the beginning, then I can see that maximum it take 1 millimeter at the time. All right. So this step is done. I just verified it, and then we can see from our list of operation that the facing it comes here. It also can be seen here. It is dedicated with the tool that I can recheck and make sure that everything looks all right. Other than that, if I go to this view, I should be able to see the other parameters of this operation. If I just expand this view, I can see that the manufacturing time also here. So if I just bringing the mouse here and wait for a while, you can see that the cutting time is actually 11 seconds, and there is 1 second of non-cutting movement. So 1 second. Well, this value seems to be too small because now I just put a random value um, for the feed rate and so on. But this is something that if you check and put the correct value, you can also figure out and calculate how much the machining time it takes. All right, but let's suppose that this is fine, and let's go to the next operation, which is the outside diameter roughing. So for that one, again, I create another operation, and this time I select the rough turn OD, rough turn outside diameter in the same program. Let's say we're gonna use the same tool. Again, it should be geometry should be put to the containment main, and then the method again roughing. For example, this is the correct name, let's say. And for this one, we have it here. We can see that already depth of cut is a bit too much. So for example, let's say what will happen if I put 1. And then, well, with this kind of a settings, it's better to always have it omit for this reversal mode. And then I'm gonna generate it again, simulate it. I will see the view of a 2D material removal, running it over. Now I have the roughing of the part, so this looks to be all right. So after that, I go to the next one, which is this finishing of the outside diameter together with the facing. So I can just create another operation, and this time I will select the finishing OD. So this is the finish OD. Let's say this time we're gonna use a tool um, with a sharper tip or smaller nose radius, so that it would be better for the surface finish. Then again, the same containment main, and this time lathe finish. I can make sure that the name is correct. And now I will generate and see that what will happen. I can see that now this is the problem that it happens because of the reversal mode, that if I just put omit reversal, then already the problem solves. I take it back again and you can see the problem. And now you can see that how the problem solves. And then again, you have the different options to put, again, non-cutting parameters and so on. And then let's generate it again, or yes. So let's generate it again and then verify the tool and see that if this is something it look like. Now we have reached the final geometry. So for now, we have defined facing, rough, and finishing on the outside diameter. Now the next one, so until now it was rather similar to the turning, except that the geometry was differently defined. Next one is defining the milling of the end slot, one of them on the surface and 3 of them on the outside diameter. So for that one, we need to create another operation. We have the tool, if I'm not mistaken. Let's check it out. I think that we have defined the tool, the end mill. I think, yes, we have the end mill one, and we have another one. We copied this one, but it could be also a different tool. So we have the tool. Let's go and create the operations. And for the operation, I will select floor and wall, which is something that is depending to the, or we are defining in the milling machine. Floor and wall in the same program, and the tool we're gonna use, let's say we're gonna use the end mill number 1 that we used. We're gonna now aim to machine this part. And then for this one, we select the machine coordinate system on the mill. And the most importantly, here, don't forget to define this correctly. So we will, for example, use mill finish polar. So we're gonna reach the final geometry in the same machining operation. Otherwise, you could also define the roughing and leave some material and then go back to the finishing. So I will just go to the finishing. Make sure that you are choosing these settings, and this is how we are deferring the post processor to give us the milling setting and not the turning setting. So then, for example, floor one, I can call the face slot, for example, or the slot on the face, or I can just give it a number and then I will refer to this number. So one of them, it would be like this. So whatever it looks better for you. Now we have this one, and now it's the time we need to define what is this, what is the working scenario. So it looks like that is already taking it correctly, but let's check it out. We can select the cut area floor, and then we can choose the floor here. And then for the ease of our work, we can also select the automatic walls. So it will just select these walls and we can double check the walls here. And now these walls are taken correctly. Then we can see the depth of cut is 0. So depth of cut, we can put just a number just to be similar as what we have done previous operation. I have now put the depth of cut 1. And let's see if it generates already the tool, if it brings up some problems or not. All right, let's verify that and let's check that how the movement it works fine. Let's see if this one, well, let's try this 3D dynamic if we can modulate that one. Yeah, maybe the speed was a bit too much. Let's see, or the quality was a bit low. Let's see if we can see it again. Well, I need to go back again and bring it again. Now I'm trying to do it in the 3D dynamic, so that's why it takes a bit of time. Now I will verify again with a lower speed so that you can see better. So this one, let's see. Now we should see the yes. So now you can see how much material it removes in 3 passes, and then we are reaching our final geometry. So I click OK. This seems to be fine. Let's check something before that. Let's take how much time it takes with this current setting. Now, noting that I didn't put any values for the spindle speed and so on, but these are something that you should be able to define it correctly, especially if you are interested in post-processing, getting the file correctly, and also taking into account the manufacturing time and so on. Well, I don't know. Let's put this one in terms of RPM, and then the feed rate was also there. But anyway, let's see how much time we have here for this process or for this operation. We have the mill turn. I can see that it takes 1 minute and 29 seconds based on this setting again. And I can see that 1 minute 27 seconds is the cutting and only 2 seconds is the non-cutting, which is already fine. But then in case you wanted to also reduce the time or in terms of a non-cutting movement and so on, this is something that you can still affect on it on the non-cutting movement. So we come here on a non-cutting movement, and if I go transfer and rapid, so movement within the area, I can define, for example, between regions. I can, for example, call it direct. And then there are different options that we can refer to. Let's put direct. And this is how perhaps you can also reduce the manufacturing time. I maybe I can verify it, but this time maybe on this mode that it would be a bit faster to simulate, and we can see that the simulation is actually taking place. And let's see if it has any effect. So, well, with these settings, it only reduced the time in 1 second, which kind of doesn't make sense much, but then you can imagine if there are different parameters or there are different geometry anyway, uh, you can reduce the non-cutting time also. So here it was only 2 seconds, so now it's reduced to 1 second. But you can imagine about the series of a time of the component or bigger size of the component, then sometimes this reducing the time of non-cutting move is something that at the end it's gonna be rewarding for your whole part. All right, let's go and now generate the same scenarios, but now for this inclined slot. For doing that, we're gonna define the same type of operations. We're gonna go there, again, floor and wall, similarly to previous one. Remember to put the machine coordinate, system mil, and then also finish polar. And so everything is the same, but now the different would be about the different cutting area. So this is again the same. Now we have a different cutting area, specified cutting area floor. So this is the cutting area floor. And similarly, again, we can check depth of cut is already 0. You can put the depth of cut. And then what we can already generate and see that what it happens, it looks like that is already good because now the software detected that the tool needs to be perpendicular to this surface and it looks like okay. But if some cases it wouldn't be it wouldn't be perpendicular, that would be a problem. And that is how we need to define that the tool axis would be perpendicular or normal to this surface of the floor. So for that one, we can go to the tool axis, and it's already actually it is in normal to first floor, or you can actually specify a vector, for example, and from the specified vector, then you can also define where it would be. But I put it now to the normal to the first one since it's already fine, but this is just to show you in case it won't be. The problem is that if the tool axis is not perpendicular to the floor one, then the quality or the surface finish would be a lot determined, and you need to have a very small overpasses so that you can still get almost a good quality. If not, then that would be a problem. Another option would be, of course, to use the side of the tool. But then if you use the side of the tool to cut these ones, then you won't get these sharp corners. So for this specific design, we need to make sure that the axis of the tool is perpendicular or normal to the floor surface that we have. Otherwise, either we're gonna have this sharp corner be rounded, which is obviously a defect. If not, we're gonna have a very low surface quality. But by just defining it correctly, the tool axis, these two problem is solved. All right, let's generate the tool pass and let's verify that. And perhaps we can again check the 3D dynamic and see it again from the original shaft. And I can see that, okay, within 3 passes it completed these ones. And something else that you can also check and figuring it out is the percentage of the um, percentage of the step over. And step over, you can see that I have the percentage based on the tool flap, or I can just define the different passes. I can define the constant value and so on. So now it's 70%. So what will happen if I put 70? I mean, change it from 75 to 50. If you remember, it was 3 passes side by side. And now let's see this one, how much it takes. It should be normally now more than 3 passes, but it's 1, 2, 3, and 4. So the more you put, perhaps you are getting more or better surface quality, but not necessarily because it's anyway increasing the machining time. So I think 75 would be rather a good number, but you can also check this one with the final quality that you get. If you machine something and you see that there is gonna be something material left, so that you can change this step over values also. All right, let's consider that this is okay and we are done by this process. And we can again see that now this is added here, but then I have a sign here that maybe it's because of not verifying it, because I changed the value, or maybe it was because I changed the value and I didn't regenerate it again. I changed the value of a step over back to 75, and now it looks okay, and now it should be fine. All right, so now we have defined this floor wall for this slot. However, we have the 3 one. So what you can do is that actually in the view of the program order, you can copy this one and please click on the program name and then put paste inside. If you paste only, it will just put it outside this program. So this is something we are not looking for. So I just right click and delete those one that they are wrong, and then I will just copy these and then paste inside this program. I will paste it twice because I will have 2 more slots to do. Basically, they are the same. Paste inside, and then I can also rename it um for the matter of finding it. So this is the floor ward number 2, and then number 3. So by double clicking this one, now it's basically the same tool and the same surface. So what we need to do, the minimum things that we need to do is to define the cutting area. So moving it from this one to this one. And actually I can see that now is both. So from the list, I can remove all of them and now select only one. Now this seems to be fine. I will just regenerate so that I solve this problem of not generated tool. Well, this one I don't need to verify, but if you want, you can. Just click OK. Now we have this third one here that we need to do here. So in case, for example, you want to study, you want to first manufacture this one and see that, okay, what is the effect of different step over, for example, you can basically define the same parameter and only change the step over to manufacture this part as one, and then you can analyze the surface roughness and so on from a different scenario. But let's suppose that this part we're gonna make it as one good para part. So we're gonna set the same parameters since we don't want to have different um, requirement or different surface roughness around this area. So this time again, I will define this, I will delete that, and I will define now this one. And now we can see that the 2 pass is not yet generated. Now it generates and everything looks fine. And then I will click all right. Okay, so this was it for this video. I will now stop here and then make another video. Then we can define the drill holes and then go into the next spindles to get the cut off the part facing on the sub spindle and then showing you the output in the next video. Thank you.